Hey, sorry about that. I was already introduced, but my name is Kalle Alm. I'm a developer working for DG Lab in Tokyo. I mainly do Bitcoin core stuff. We also do some other random stuff, but DG Lab is basically a hardcore Bitcoin only organization, which I'm proud to say. I'm going to talk a little bit about threat models and also a bit about application development, an RPC app in this case, using the Bitcoin Core RPC interface. So there's two sessions, sort of. Well, there's one session today, the one now. I will be explaining stuff today. And tomorrow there's a workshop where we'll do some hand-holding to actually do the tasks that I have here. I've done this session one time before in Japan, in Japanese. And there were about 100 people there. One person finished all of the tasks. So, but I did a poll, and who did not see this poll, by the way? Oh, whoops, OK. Well, anyway, but it looks like the guys here are a little more advanced than the regular crowd. So as you can see, it's like intermediate advanced on the programming code-wise side. And blockchain tech-wise, seems like you guys want a challenge. So that's good. There's a Telegram group, and I'm going to actually send that out now. And OK, I tweeted the slides, because you're probably going to want them eventually. And let me see your Telegram. Where is it? That's Twitter. Telegram. OK, so I put out the slides and the invitation for the Telegram group on Telegram. I don't know if you use Telegram. I don't, but I made an account as an exception for this conference. I will burn my account later. So anyway, join the group and ask if you get stuck. I highly suggest you do these tasks, even if that's a pain in the ass and you'd rather go out and drink beer with everyone else. But also, take the opportunity to kind of like get together with people and do things together. Find someone on your skill level or above you. You should be the stupidest person in the room. And see if you can do them. I highly recommend doing that. And you can ask me directly or in this group if you get stuck. So today, this session is, I'm going to talk a little bit about environment, not the environment that green people talk about. I'm going to talk about the environment on your computer. And then I'm going to go into talking about confirmations, reorgs, threat model. Then I will discuss, I will explain a little bit how the RPC app that we're going to fix or make, and then some tasks. So this RPC app is not flashy at all. It's not Lightning or anything like that. It's just a regular layer 1, old-fashioned, old-school Bitcoin app. So if you don't like that, then yeah, maybe you should do a better app on your own and tell me about it. Anyway, so environment. So Bitcoin Core has 2 ports. You guys are probably familiar with this. There's a peer-to-peer port and an RPC port. So make sure you connect to the right one. The difference between these two is kind of big. So the RPC port is basically like giving someone your wallet, like, you know, hey, here you go, and then take whatever you want. The peer-to-peer port is completely trustless. You can connect to anyone on the peer-to-peer port. You're not going to lose anything. So you don't want to do something like that. You don't want to make an app that is based on connecting directly to the RPC port, which is open to the world. That's not a good idea. So a better solution looks something like this. Well, this is an example anyway. You have a full node and an RPC app, and they're kind of in the same environment, probably even on the same server. And then you have users, and they use your RPC app interface thing to do stuff, like we're going to do later. Here's a way to do it. You just make a full node, a Bitcoin Core one, and you make it in a safe, secure, fine location that is not hackable, preferably. And you make an RPC app that connects to the node, and you add a bridge out to the outside world using this RPC app, where you will presumably not even have anything like send to address or stuff like that. And then users connect through an app that talks to that. And so the RPC app that I'm talking about here is basically number 2 here. So we're not going to do anything of any of the other stuff. We're just going to make a simple command line interface to just do stuff with like invoices. And it's a payment processor basically. So usually the RPC interface is not it's restricted. So you can open it up using. If you use Bitcoin CLI, you can use minus data there, and it would use this RPC cookie thing to authenticate. Or you can just use like RPC user and RPC password, which is they're kind of supposed to be deprecated, but we're actually going to use that one in this app because it's simple to do. So I'm going to we're not going to do this now because none of you have your computers out, but you basically create the bitcoin.com file, so you have the RPC user and password in there, so you can connect from your app to your Bitcoin Core node. And so this is what we're going to make. We're making an app that we can create invoices for people, and we can verify payments, and we can check and react appropriately to like double spends and reorgs. By the way, reorg, everyone knows what a reorg is? You don't know what a reorg is? You seem to know what a reorg is, OK. All right, so some of you may balk at this, but the environment used here is Node.js. I encourage you to rewrite the whole thing in Python or whatever you like. Rust, maybe? Rust sounds like a good idea. We're also using 2 like Node.js packages for just talking to Bitcoin RPC. And unrelated code I've written for you. So you're actually just going to go in and fill in gaps in places. So it's not a lot of code. It's maybe, I think, 50, 60 lines of code in total. But it's very educational because you'll see that there are lots of edge cases where like a double spend attack can lose you money and stuff like that. So you can do the git clone command here to get started. Actually, you may not be able to do that because I think it's private. I'll open it up. Anyway, so you can just do that. And you may need to export Bitcoin path. So you do need to have a Bitcoin Core instance installed on your machine. And if you don't have the Bitcoin path, if you don't have it in the path, you may need to export Bitcoin path before you use it. But minor detail, but so in this app, there's already a test framework. You can run an npm test to test all these kind of cases. It will try to double spend the shit out of your application and try to fool you in various ways. So if you can get all of those tests to say check, which 1 out of 100 people managed to do last time, then you've convinced me, actually, sort of. I actually realized that there's a way to fool this later, but anyway. Yeah, so that's about the RPC app. So I'm going to quickly talk about confirmations because I think you guys are familiar with most of this. But right, so we have a block. In this case, it's block number 123. There's a transaction in there, 27C. And at this point, it's got 1 confirmation because it has 1 block. And if we make another block, or if someone makes another block, it now has 2 confirmations. And if you make another block, it now has 3 confirmations. It's very, very straightforward. So, but what happens if you get 2 blocks at the same time for block 123? So on the A side, you have this transaction that we're talking about, that we care about. Someone sending us money. Someone sent us money here, but no one sent us money over there. So in this case, we're happy, and in that case, we're not happy. So there's a difference here when 2 blocks are mined simultaneously. But this is resolved pretty quickly. Actually, yeah, I should probably mention that you have 0 confirmations over here and 1 here. This seems obvious, but we'll see later that what happens when we have an actual double spend. OK, so if in the first case, someone mines on the A side first, and then we're happy. Our transaction now has 2 confirmations, and the other one is kind of, the other block is probably not going to be mined onto because we already have one height here. It makes more sense for miners to go here rather than here unless they really hate us, which is possible. Miners have opinions too. And in the other case, we probably get our transaction mined in there because there's no reason for miners to not mine it unless they hate us, which they might because miners have feelings too. And in this case, here we have 1 confirmation, and there we have 1 confirmation. So one lesson here is that even if you have a block mined, you're still going to, the number of confirmations don't automatically increase here. You may have the same. So, and if you have simultaneous blocks here again, you have 2 here and 1 here. But now someone could build on top of one of these, and you don't know. So, so that's unfortunate, but it's not that bad because eventually our transaction went in anyway. But if you have like this, where you have this is our friendly transaction that we like. We'd have the same hash and same index, meaning it's the same UTXO here, and it's going to 1 ABC something here. And then we have 45E over here, which has the same hash and same index, but it's all going to 1 DEF instead. So this is us, and this is evil person, and we prefer this, but both of these exist. So in this case, we have the evil transaction in the B block, and we have our transaction here. So as you see, we have -1 transactions for the evil one here and +1 for ours, and we have the opposite case on the other side. So suddenly we have minus confirmations. So you can have like -5 confirmations for a transaction, and that means it's been orphaned 5 blocks away from where you are right now. And as you see here, if someone mines on the B block, then we now have 2 confirmations on the bad one and -2 for ours, and we're probably not going to see that money. And the other way would be better for us. So that being said, we're going to talk a little bit more in general about threat models. So basically, this is kind of straightforward. You should probably realize that you don't realize certain things. Certain things are different with Bitcoin compared to other development. If you're a web developer and you come into Bitcoin, you're like, let's do this. You're probably going to lose money or someone else's money. For example, you're at a casino, because everyone who likes Bitcoin likes gambling, so I'm going to take a gamble example. That was a joke, by the way. So here, if you have heads, you win 200 pounds. If you have tails, you lose 100. Should you play or not? Well, that depends on the information you have, right? If you have no information at all, it's probably going to be like 90% tails, so you're going to lose all your money. But if the coin is minted by the government, and you know it's like, or if they even use your coin, you just give them a coin and they use it, then playing would probably be a good idea. You would win 20,000, lose 10,000, so you would get 10,000 or something like that. So the threat model on blockchains, like I said, it differs. People lose money regularly, and there is tons of completely insecure software out there. You may have been using it without knowing, or even intentionally. This was that a couple of days ago, 3 days ago. I don't know if you saw this, but I mean, these are the kind of things that you have to kind of, you have to kind of take into account if you're dealing with $190 million, right? So anyway, so Sybil attacks. I know about Sybil attacks. Raise your hand. Wow. I should probably go fast. OK. All right, so normal case, poker at a casino. We have everyone is playing poker, and everyone's playing for their own benefit. That's what you expect when you're playing. But what if everyone except you is hired by the casino to play against you? Then things could change. In the Bitcoin network case, here we're our node. This is our node, and we think that all these nodes are different people with different opinions, and they're all neutral. But in fact, they're all the same person. So how does the security model change when we have this case in Bitcoin? So you can do, there's several types of Sybil attacks. I'm not going to go into much detail because you guys know about them already, but you can attack a specific target, or you can do some kind of partitioning thing on the network, which would delay communication between the two sides. And you can do this by doing slot exhaustion, or just swarming the network with nodes. Nodes are very cheap to set up and start, especially fake nodes. You can do some kind of man in the middle thing, or if you're an ISP or something, or friends with an ISP, you could cut fibers or do things like that. So preventing Sybil attacks can be a little tricky, but if you have if you're in exchange for something, you may want to have like multiple nodes in different locations geographically, and you may only connect to your own trusted nodes over VPN. BIP 150 is one way to help mitigate this. So, all right, so double spends. Has anyone ever used a cheque, by the way? Oh, wow, okay. Yeah, I never used a cheque. An American gave this example to me, and I was like, huh, that sort of makes sense. Anyway, so you deposit a 300-pound check in an account, and you have 200 in it already. So now you presumably have 500, and you withdraw 400, and then that check bounced, and now you have minus 200. That's, if you'd waited, it would have been fine. This Bitcoin kind of works the same way. So if you wait long enough, you're generally fine. If you take zero confirmation transaction and you just, okay, I got my money, whoa, and then you run off, then you may lose that money. So so it appears like you got money, but you didn't. One easy way to do this is you create a low fee and a high fee transaction, spending the same inputs. And then you send the low fee transaction to your victim, say, here, I'm going to send you money. And then you send, once they say, oh, thanks, we got it, you just send out the high fee transaction to the network. And it will work out that nodes will presumably see the high fee one first, and then they will not even accept the other one. They will that's a double spend, we don't care about that. So there's a real case of this happening. Peter Todd did that against CoinCheck, I think. No, he did that against Coinbase, sorry. Coinbase, CoinCheck is the Japanese one. And so if you want to read up on that, you can do that. You could do malleability stuff. This is not possible with SegWit. Thank you, SegWit. But you could do this with pre-SegWit stuff. You could make a chain of transactions that are all zero-conf, and then you could resign the first one or malleate it somehow. And then all of the other ones would just become invalid once that is mined because they're now double spends, or they don't even have an input anymore. Other cases, like we talked about for the Lightning case, there was a wallet that crashed, a Lightning wallet. This can actually be a problem with a regular wallet too, because if a wallet crashes and the UTXO database is not updated, then the wallet may reuse UTXO that was previously spent from and try to double spend, even though that was not even the intention. So so it's not always malicious. It could be a complete problem with software and not user. Another common, I would say the most common double spend is replaced by fee, which is just where you just bump the transaction. I once tried to double spend myself using a replaced by fee. I sent money and realized I made a mistake, and I wanted to send it back to myself. It did not work at all. So RBF is it's kind of assuming that you're sending to the same place. So if you try to RBF back to some other address, which looks like it's working if you look at the code, but doesn't actually work that well. So I learned that lesson. That was a sad day. So yeah, so the conclusion here is wait for confirmations when you transact. If you're sending someone $1 billion, you may want to wait a few confirmations before you or rather, someone sends you, I guess. Okay, so if you're double spending during a Sybil attack, you have a lot more it's a lot easier. Things become way less complicated. You can just not show the real transaction to the user by having your nodes not send it. You could skip showing the block to the person. You could say, oh, there's be no blocks. Or you could show a fake one to the victim and then show everyone else something else. You could even do a fake. You can make a block and not submit it with the fake, proof of work block if you wanted to, but that would be kind of hardcore. So anyway, so business logic side, you can have unsecured environments like access to private keys, Bitfinex, and a funny example is I don't know if you guys were around, but there was this web wallet back. I think it was using the Bitcoin Core account feature, which was horribly bugged and has been removed. But so basically, the web wallet would send a get balance for the account of the user, and then once it got back the balance amount, it would see if that balance amount was higher than or equal to the amount the user wanted to send, and if it was if they had enough in their account, it would do the send command. The problem here is if you hit submit twice fast enough, you're going to have like get balance, and you see 1 Bitcoin, and send 1 Bitcoin, and suddenly the user has -1 Bitcoin, which works because the Bitcoin account system didn't care about balances. It just cared about like trying to group things together. So you can also have programmer errors. Like the most common one is nonce reuse, where you just reveal your private key, which is sad. I mean, SPV wallets, if they're not to be trusted, you can use them at best to just to sort of pretend that you have a wallet. Block explorers, similarly, they can be arbitrarily changed or modified to tell you something that's not the case. I mean, I could go into cryptography breakdown too, like a weakness in elliptic curve cryptography. I think that some people will disagree with this. Even I may disagree with this. But even if EC was broken, hash functions could kind of help keep things secure anyway. But I think we're actually moving away from that. So we're probably going to use public keys without the hash in the future, probably. I don't know, but we'll find out. So address use with an EC weakness would be super bad, and that's probably going to be the case no matter what. So consensus error. So there was this coin called PP coin, which was a clone of Bitcoin Core, and so BIP66 was fixed, and then PP coin kind of didn't fix that, and then there was a hard fork in PP coin because of the fix that was in the BIP66. But consensus error would be where the chain kind of hard forks, even though no one wanted that to happen. I think we've had cases of that a couple of times. I may be wrong. Anyway, so to kind of you can have nodes in multiple locations. You can even run different versions of the software to kind of detect this happening. And when a fork occurs, you could pull brakes and raise alarms. I used to say that when a fork occurs, well, the last time I said that when a fork occurs, make sure you put all transactions on both sides. But that's complicated now because people are stupid. And they think that even useless things have value. So if you have two forks, you may have value on them, and Anyway, so that's enough about the threat model. I'm going to talk a little bit more about the RPC app now. Time's up, apparently. So I will just not do that, I guess. Let's see. Well, I'll just see. OK. Yeah. Was that 30 minutes or 45?
That was a little less than, yeah, you can take like 5 more minutes.
OK. OK, yeah. All right. So the RPC app, we create an invoice system. And I guess I will probably cover a little bit of this at the workshop tomorrow, which is where I encourage you to do this if you want to. There's 2 workshops. There's one other one which is aimed at new people to Bitcoin. I don't know which one you want to go to, but I think I will just describe these stuff tomorrow because we have 2 hours, which is, I mean, you have the slides, so if you're interested in trying it out, you can try it out. Otherwise we'll do it tomorrow. All right, thank you very much.